All right, so let's go ahead and get to the next part here, and this is slope. Actually, yesterday you might remember that I was talking about two lines. In fact, let me go ahead and just write them down. I was talking about two lines, so you have two lines like this that intersect, and then if you were to take that same angle and repeat that same angle, that would make these two lines parallel. So if I have the whatever this is, however many degrees this is, if that's the exact same over here, that is one of the proofs that we would have that that these two lines are parallel. But one other way I described it was that they're both heading off in the same direction, and that's kind of what we're doing today. We're checking to see if these lines are heading in the same direction. So we're going to have to go back thinking about algebra 1. So if you remember algebra 1, we did a lot of these y equals mx plus b's, linear functions, line graphs. They go by different names. And one of the big things that makes the line graph is that they have slopes and intercepts. But today we're going to focus mainly on the slope part. So slope review, classifying the slopes. So slopes come in a small amount of differences because everything's going from left to right, okay? So just like most video games or the direction that you read, everything is going to be kind of measured from left to right. So start from the left, and if I'm walking along and I run into this line, I'm going to be going up. So that's why we call that a positive slope. If I'm going up and then I go along this line, well, if I'm staying on that line, I'm going to have to go down. So going down. That's why we call that a negative slope. Then zero slope is basically something that's just straight sideways, right? There's no slope. Sort of like the floors of most buildings. In fact, it would probably annoy you if there was ever a building that had a slight slope, because everything you drop would roll to one side of the wall or something like that. That would probably get annoying. So most of the time, we try to make buildings that have a zero slope. And then you have an undefined slope. Well, this is different than a zero slope because a zero slope, you could at least walk across it. But if you run into an undefined slope, it's like a sheer wall that you just can't get past, right? How would you get past that? Can I climb up? Well, don't forget, these lines go on forever. So how do you climb a wall that goes on forever? Well, you can't. So that's one of the reasons why we call it undefined. There's actually a lot of reasons we call it undefined. And that's just one of them. Anyway, so those are the 4 different kinds of slopes. How would you find a slope? So if you have a graph, which is what we have here, we have a graph. The slope, and that would be the m value, we call it m, y equals mx plus b. And the easy way you can remember that that's the slope is that it looks like a mountain. And that is used with 2 numbers. Sometimes it's 1, but really there's 2 numbers. And those 2 numbers, if they're put into a fraction, will make the top number the rise. So how much does the line go up? And then the next point, where does it run to? So here I have A and B. Those are the points we're given. Sometimes you can find an easy, a lower point or a sooner point that they will meet up at. But in this case here, I'm pretty sure that this is going to be the earliest they can meet up at. So if I look at the rise, so starting from A, again, starting from left to right, 1, 2, 3, 4. So if I go up 4, I would be on the same level as B. So up 4, and then I'm going to have to go to the right until I meet the point B. 1, 2, 3, 4, 5. So up 4 over 5. Rise is 4, run is 5. So again, run is the sideways, sort of like the way I was talking about a person walking along this. Well, if they go 4 spaces to the right, well, they're also going to have to go 5 spaces up. I'm sorry. If they walk to the right, they're going to have to go 4 spaces up and 5 to the right. And we talked about negative slope as well. So negative slope. And they give us the points here, P and Q. So I'd probably have to go down first. So 1, 2, 3. So we go down 3. And then that puts us at the same level as the other point, Q. Okay, 1, 2, 3, 4, 5, 6. So down 3 over 6. Now remember what I was talking about when I said that there are sometimes points that you can meet sooner? Well, if we look at this fraction, it's not in lowest terms. Since it's not in lowest terms, well, we should reduce it just like we reduce any kind of fraction. So 3 and 6 can both be divided by 3. So I'm going to divide this by 3. 3 divided by 3 is 1. And then 6 divided by 3 is 2. So divide both the top and bottom by the same number, which again is 3. Don't forget the negative. The negative has to stay there because this slope is negative. It's going down 1 over 2, down 1 over 2, down 1 over 2. Okay, so that's why we reduce the slopes. Okay, so let's look at the next one here. So number 3, LM. So it looks like we're going from M to N. Sorry, I had to do a little bit of alphabet there to know which one was going where. Usually it goes in alphabetical order. So from M to N, it looks like we go down 6. Well, that's actually a good point because here they put positive 6. So is it going up 6 or is it going down 6? Well, that's another problem that we have. If it's going straight up and down, it can be either negative or positive. And it's really not either of those things either. Because I can, again, go up 6 or down 6. But either way, we're not having any run sideways. So there's absolutely no sideways movement. And that's going to cause, well, that's going to cause this to be 0. And anytime you have a number like that, well, this one's a very confusing part with most students. So, you know, if I have like 0 divided by 5, well, that becomes 0. And that makes sense because if I have 0 Skittles and 5 people, well, nobody gets Skittles because we don't have any to share. But the thing is, you can't go backwards with that. You cannot say 5 divided by 0 because this is what you have and this is how many groups you're putting it into. So how do I put something in 0 groups? Well, you can't. You can't put something into 0 groups because the lowest number of groups you could have is 1. All right, but anyway, let's see what happens when we do this 5 divided by 0. So again, 5 Skittles for 0 people. So this calculator tells me cannot divide by 0. So cannot divide by 0. And that's one of the other reasons why we call it undefined, because it can't be done. You can't divide by 0. All right. And again, that's different than this one here, where if we look at from J to K, right, we go up 0. We don't go up or down at all. We just stay at 0. Go over 3. 0, 3. And if you remember on the calculator, if we have 0 divided by a number, you get 0. Because again, top number is what you have, bottom number is the number of groups. So if I have 0 Skittles and 3 people, well, nobody gets Skittles. If I have 6 Skittles and nobody, well, what's the point in having Skittles if no one's going to eat them? Okay, so I'm gonna go back up a little bit more. Hopefully you can see the top of this one here. So this is how you do the slope when you are given ordered pairs. So ordered pairs are those, right here you can see I have point A, which is -2, 5, and B, which is 6, -1. So you would just take those and you would pick one to be, well, I call them group 1 and group 2. So here I have group 1, group 2. So the group 2 actually goes first in this case. So if we label it 1 and 2, and this should also be reviewed, not only because you were in geometry, but you were also in algebra. And I know this is something they teach in Algebra 1 because I taught Algebra 1. So 2 here, right? We put them over here. Well, X and Y, right? The Y goes on top because if you remember, the Y is this axis on the graph, the up and down one. And the bottom one is the x-axis, which is the sideways one. So grab 6, put it here, -1, put it here, right? Y goes on top. Now it's a minus, so each of these are a minus. So if I grab the Y value here from group 1, so Y of 1, put it right here, so 5 goes right there. But there's a bit of a problem with the other Y, is that it's a negative, I'm sorry, the X, it's a -2. So I end up getting 6 minus -2. And they skipped a step. They just put here a plus, because if you remember, if you take away a negative number, that just turns it into a plus sign. It turns it positive, right? And just a quick explanation, if you have something bad, right, and that bad thing is removed, well, that's good. All right, now just do the math. Top number, -1, -5, put them together, you get -6. 6 plus 2, that's going to be 8. So that's going to be -3 over 4 when you reduce it. So again, reduce by dividing top and bottom number, in this case by 2. They have to be able to be divided by the same number when you reduce them. So anyway, that's how we have our slope here. All right, same thing here, plug it in. And here I have 3, so that's Y, that's this value right here, -3. But because there's a negative right here, I plug it in. Then there's already a negative. Now I have 2 negatives. So rather than saying 7 minus -3, we just change it to +3. And then the same thing with the bottom number, actually, because it looks like here we're trying to subtract 11, but there's already a minus there. So you have to make sure to flip it. And like I said, I'm not going to spend too much time on this, because this one hopefully is just a reminder for you. Add them. Check it to make sure you can simplify them, which in this case we can simplify. Well, actually 10 can be divided by 5. 10 can be divided by 5 and we get 2. And that's it. The slope is just 2. And remember how I said that usually it's 2 numbers? Well, in a way you can kind of make this into a fraction. If you remember the real numbers property, that's things like natural, whole number, integers, and that kind of thing. One of the classes of numbers was rational numbers, and that is numbers that can be written as a fraction. In this case, it's not written as a fraction, but it can be, because you can write it as 2 over 1, and you would still get plain old 2. So in this case, if we were to follow the slope, we'd have to go up 2 over 1. All right, next one. So here's our points. And again, we're going to plug them into our formula up here. And now we kind of have a problem here, because X and X match on both points. So what that's going to cause this to happen is that we're going to end up with a 9 minus 9, which is going to be 0. And that's going to lead to an undefined slope. So this, I mean, even if we were to graph it, so over 9 down 4, over 9 up 2, so that's going to, if I'm using this graph, okay, it would look like it's going straight up and down. That's an undefined slope. So yeah, we would write undefined, not 0. Don't confuse it with 0 or anything else like that, or don't leave it as 6 over 0, because again, that's a big no-no in math. You just cannot have any numbers divided by 0. All right, next one, find the slope here. So again, just plug it in. And in this case here, 0 became our top number. This is fine, this is fine. You can have 0 as the top number, because 0 can be divided by anything. It's just going to stay 0. And that's what we get 0. All right, I'm going to go ahead and move on from here. And I'm going to go ahead and leave it here for a bit. Well, actually, you know what? We don't really need to all that much, because here you can just pretty much just look at the lines here. So I'm thinking that's the way it's written on the original. Actually, you know what? I have it right here. So I'm going to go ahead and look it up while you are Yeah, so they give you just the lines, and it's up to you to find out what the slope is. And you can see right there that already you have some of them that you would need to plug in. So some you use the graph, others you plug in with. And actually, you know, we're a good ways through the packet, really. All right, there is, it looks like there is one, what's going on the next page? Just look ahead really quick. Okay, so they talk about, okay, parallel and perpendicular. All right, so let me check out what the time is like. Okay, we got about 30 more minutes. So I might be able to cover this next one, but we're gonna have to kind of rush through this one here a little bit. All right, and hopefully you've been writing these down. I'll be right back. Got me a stopwatch now. Okay. Just had to get me a water. Well, at least we got clouds today. That's good. I mean, at least it was one day where I didn't wake up like all hot and stuff. All right, so let's see. Find the slope of the following lines. So they kind of have these dots. In this one, it's a little bit hard to see. So you just go, let's see, from one dot to the other. So up 2 over 6, 1, 2, 3, 4, 5, 6. So we write 2 over 6. Now, anytime you have a slope, you should always write down the simplified version of it. The simplified version is going to be, or sometimes we call it reduce. Sometimes people will say reduce your fractions. But in this case, it means the same thing, reduce, simplify. So sometimes I'll use one or the other. And that's all that's happening, is that we're just going to go ahead and write them down like that. All right, I'm going to move down here. And you can see that they're just plugging them in. So one group, usually it's the second group that goes first. Although actually you can flip these. You can flip them so that 17 and 4 go first. Or, well, here they are going first, but you know, 8 and negative 11 could go first. You would actually get the same answer. A lot of times, well, actually almost every time it's gonna balance itself out. So there you go. Yeah, like I said, I'm not going to spend too long on this, so I'm going to give you a few minutes to write this down. And again, this is sort of review. I mean, even for Algebra 1, it would still be considered some review. Okay, that's been about 2 minutes now. So maybe another few more seconds, like 30 seconds, or maybe another minute actually, I don't know. Quite a bit of writing on this one, but all right, that's about 3 minutes. So I'm gonna go ahead and move on down. So I'm not too sure how much different this one's gonna be. I mean, time-wise, like, is it gonna take me a while? Is it gonna not take me a while? It just looks a little bit different than what I would normally do. So I'm gonna go ahead and just kind of err on the side of safety. And we're just gonna move on from here. Let's see, move to a spot where we can see most of it. Maybe about there. I mean, that's about the most I can do with showing a large picture and being able to read it, because I know everyone's got a little bit of a different screen. Some of us might have big computers with a 1080. Well, actually, I don't even know. Is 1080 still like the big thing? I don't know. I heard some people talking about 2K or something, or 4K. But some people would have a high definition. Some people are just watching this on their phone. So I'm gonna try to get everybody accounted for. And I'm gonna go ahead and give you, again, some time. Actually, I should have set the timer again. Okay, there we go. And another, I'll make it 2 minutes. This one's got some writing, but it's not really that much writing. Okay, it's been about 1 minute. All right, that's almost about 3 minutes. Just come on, someone's texting me now. All right, let's go ahead and go over this now. All right, so let's see what we got. First thing, we're still talking about parallel lines. So parallel lines are lines that have the same slope. And we still use that same symbol that looks like an 11 with both lines parallel to each other. Perpendicular lines, now this is the new one. This is the thing that we're looking at in addition to what we normally would. So perpendicular lines have a negative reciprocal slope. Now, sometimes we call this opposite reciprocal, and opposite usually means like if it was positive, then it's negative, or if it's negative, it would be positive now. So how exactly do you get that? Well, we're going to go over some examples. So negative reciprocals. So take a closer look at what they mean by that, and that is to change the sign and flip the fraction. So here's some examples. 3 over 4. What is the thing of 3 over 4? The negative reciprocal. Okay, so first off, change it to a negative. So now instead of positive 3/4, it's going to be a negative number. And instead of 3 over 4, it's going to be 4 over 3. So flip it. So we flip it, and that flipping is the reciprocal. So that's what reciprocal means. Reciprocal means that we flip that fraction, right? So instead of 4 over 3, it's going to be, it's 3 over, okay, 4 over, it's flipped. And then over here, well, what do you do if there is no fraction? Now, actually, we've seen this one before. Remember how I had a slope of 2 on one of them, and I said you can write it as a fraction? Well, yeah, you can. You can write it as 2 over 1. Because 2 divided by 1 is still going to be 2. So you're not actually changing the value. That means what the number means. But 2 over 1 is still the way you would do it. And that's why when you flip it, you get 1 over 2. So that's how they got that's where that 1 came from, because in a fraction, if you want to turn any number into a fraction, you put a 1 under it. And again, it turns from positive to negative, so it's going to be the opposite sign as well. Over here, so we have 7 over 8. Flip it to 8 over 7. It was a negative number, but now we take off the negative, so it's going to be a positive. So change the sign, flip the fraction. Now 1 would be pretty much the same thing. 1 is one of those numbers that is, well, the opposite really doesn't change that much. It just goes from 1 to -1. And to flip the reciprocal, even if I put a 1 under it, that's not going to change because 1 divided by 1 is still going to be 1. Or that's one of the properties of math, and that is anything divided by 1 is just going to be that same number. So yeah, it doesn't really change that much. 0 and undefined. So if you remember the slope 0, right? Or if I pick any number like 0 over 5, and then we change it, we get 5 over 0. Well, -5 actually, but the important thing I wanted to point out with this one is, in this case here, we can't do that because you cannot divide by 0. It's just one of those big no-nos in math that you just never do. So be careful with that one, because again, it would be undefined. I know some people might say something like, well, it'd be -0 or something like that, but there is no such thing as a -0. Let me go back down here. So hopefully everybody got that top part, because I'm going to move down now. And we're going to get ready to go into the next two, but if you were missing, because I know that those bottom two, you probably didn't see them. So if you're working on those bottom two, I'll give you about 30 seconds to or well, you don't need to finish them, but just get them as far as you can. Well, maybe a minute, just like 1 minute, because I know you only need those bottom two. About 40 seconds on there now. Okay, I'm gonna get ready to start the next, start moving on. Okay, so again, it was only for those bottom two, so that's why you didn't get as much time with this one as you normally would have. So here we have our lines A, B, sorry, those are not lines. Those are ordered pairs, A, B, C, and D. So from line A to B, so we take the points from A, in this case here, -2 and 3, and we're gonna plug them in. And again, normally they make them the second one, but you would use that formula that we had earlier. And just plug them into that. And again, watch your signs because the signs can change, right? Because here I have an X that is -2. And since the X is -2, well, if we plug it into the formula they gave us, it's going to already have negatives in there, and those negatives are going to cause it to become positive. So watch out for that. And then just carry out your regular old stuff here. And oh, they're asking for the slope. So the slope from point A to B. Okay, so it took me a while to look at this because I was like, it's a little bit different for me also. And again, this is stuff that Mr. Moreau gave me, so I'm just working with what he has, and I'm not normally a geometry teacher, so it's not like I can really, I've never seen this lesson before, basically. And normally I do a little bit of a look ahead sometimes, but today I just didn't. It was just a busy day yesterday and today. All right, so from point A to point B, that's what it's saying. So if you were to draw a line from A through B, that would be the slope here. Now they're asking for the next slope, the slope from C to D. So here's C, there's D. And each of these are their own lines. So once we plug in C to D, plug them in, work them out, we get 3/4. 3/4, and the slopes match. So that means this is going to be a set of parallel lines. And then let's go and move to the next one. So we have slope from A to B. So take your A's and B points, plug them into our slope formula. Again, watch your signs, make sure you put the numbers in the right spot, because that's one of the other things that happens that I noticed, like when I'm checking work, I always see the numbers being put in the wrong spots and it doesn't quite work out. So you got to make sure you put them in the right spot. Sometimes it's good to label them, and normally I would label them as I do these through them. So I'll put like 2 here, 1 there, I'll show you where each number goes. But anyway, working the top number, bottom number, and we get 2/5. So the slope from the line through A to B would be 2/5. And then from C to D, so going through from C to D, plugging this in from here, so 1 and 8, so there's 1 and 8 right here. Plug in 3 and 3, so 3 and 3 are these numbers here. Subtract them, so 3 minus 8 would be -5, 3 minus 1 would be 2, and that's our slope right there. So again, check to make sure it's in simplified form. If it's not, then you'll have to simplify it or reduce it. and put it right there. So now we can look at our two slopes for each of these lines, and it is going to be perpendicular because again, they are opposites. One is positive and one is negative, and they are also reciprocals. So reciprocal 2 over 5, 5 over 2, they've been flipped. All right, so same thing with this one here. A and B, plug in your points A and B into this one, work it out. C and D, plug in these points over here, work them out. Line, and now that we have the slopes for both line AB and CD, okay, well, they're not the same, so they're not parallel. They're not, well, they are opposites. One is positive, the other is negative, but they're not reciprocals. So don't be too fast to say it's perpendicular if it's not parallel, because sometimes they can be neither. In this case, they are neither, because these lines are not doing anything. They're not, if you were to graph it, parallel lines obviously look like that. And a perpendicular line, a set of perpendicular lines would look something like that. And in this case here, I can't tell what this line would look like. I could probably figure it out, but that would take a little bit longer. You might have something that looks like this. So they are likely going to intersect, but they're not going to intersect at any 90-degree angles. And actually, it just sort of occurred to me, I don't think they actually told exactly what perpendicular was. I'm going to check that really quick. So they never really, well, we already kind of covered perpendicular lines, but it didn't really give like a really good example of it. So I think you guys are able to put it together. You're bright enough. You remember what perpendicular lines were. Anyway, let's go and do the last one here. So take these, plug them in, work them out. And in this case here, we have 3 over 1. And see how they take the 3 over 1 and they get rid of that 1 at the bottom to just say 3? So if you can go with whole numbers in anything, really whole numbers are just kind of better. That's the way we talk about things in life. So if I said something like, how many Pop-Tarts are in this box? We don't say 8 over 1. We just say 8. Well, there's actually none in that box, but you get the idea. So we wouldn't say 3 over 1, we just say 3. But here we can see that they are opposite. One is negative and the other is positive. And they are also reciprocals, because this one should be 3 over 1, but we changed it to just plain old 3. All right, so we got about a little bit over 15 minutes left, so we should have enough time to finish this last page. So I'm going to go ahead and move over to this here, and I'll let you start working on it. So let's see, 5 through about 8. You can probably see a little bit of 9, but it's a lot of the same sort of thing. I'll let you write it down. We'll go over it, and that will be it for our Zoom part 1 today. So I'll just park it here, let you work on it. Oh yeah, let me time this as well. Let's see, how long would this one take? There's a lot of little numbers in there. I'll give it 3 minutes. And even if you don't get all the way down, there will be a bottom part too that we'll cover as well. So hopefully there'll be time for that as well. Okay, I'm only missing one student today. So just make sure I get my attendance correct. And it's about 2 minutes, a little under 2 minutes now. So we'll bring it back in a minute. This makes it a little bit easier. Now I can keep my times a little bit more consistent. All right, I'm going to move down. Hopefully you're at least done with 5 and 6. Move down to 7. Okay, I'm going to move down again. And we're actually kind of running out of time, really. We'd have about 5 minutes left. Well, actually, we covered 4 pages instead of the usual 2, sometimes 3. But this one was a fairly longer than usual lesson. It's a review, so there's a lot of it. Hopefully, it's not too much on you at once. All right, so hopefully you got the bottom part in. I'm gonna see if I can get through some of these. And for this one here, I'm not gonna focus too much on the work. I'm just gonna focus on mainly the relation, because that's the thing that's kind of new, is parallel, perpendicular, neither. You know, those are the things that are different. So I'm gonna go ahead and go starting from the top. And again, I'm just gonna focus on only how the lines relate to each other. So once we figure out the slope here for this line and this line here, -4, -4, well, again, if they match, they are parallel. If they are reciprocals, and what's the word they use? I know they use a different word. Opposite, negative. Yeah, negative reciprocal. Now, negative reciprocal, that sounds kind of weird because this one went from negative to positive. So I know some people are going to be like, well, what do you mean by negatived? Well, that one doesn't really make sense. But remember, if you make a negative and you take it away, that's going to turn into a positive, and take away and negative are kind of the same thing. So in a way, I think opposite sounds better. But then some people confuse the word opposite and reciprocal. So anyway, still, they are opposite and reciprocal, so that would be perpendicular. Now these ones here are reciprocals, but be careful because we have 2/7, 7/2. They're actually not reciprocals and opposites. So they're not really perpendicular. So in this case, it would be neither. So be careful, because again, they are reciprocals, but they are not opposite signed. Here I have one that's negative, negative. Well, no, you know, that there's nothing saying that they can't both be negative. So someone might look at this and be like, well, if they're negative, that means they're perpendicular. No, no, no. If they are exactly the same, no matter what direction, what number, then they are parallel. Now these next two are going to be kind of tricky. So looking at the slope here, we have an undefined slope. So that's going to be straight up and down. Now undefined doesn't mean no answer or cannot be solved or anything like that. It does not mean that. It just in this case means that we have a straight up and down line, and then we have another line that's 0. And if, you know, just looking at my hands there for a second, you would have seen that it was a perpendicular line set. So again, undefined does not mean cannot be solved. It does not mean, you know, we just stop right there. That's not what it means. Undefined is something specific. Anyway, let's go ahead and go over here. So number 10, we have 2 undefineds. And again, we do have an answer from this. The answer is that these 2 lines are parallel. And if we look at 2 undefined lines, that would look something like this, right? We would have 2 lines going straight up and down, and that they would be parallel. So they would be parallel. And last one here. Given A is given that A is -9, -2, find the value of X so that these 2 lines will be parallel. All right, well, set their lines equal to each other. When we plug them in, well, we know what A and B are, right? Because we have A and B, we have that as a full set. So we're going to find that slope. So we know that the first line has a slope of 2. So what we need to do is we need to make the second pair B and C, but you notice that C is missing one of its numbers, replaced with X. So we're going to set it up, and we're going to try to make this equal to 2. And we're going to have to do some basic algebra stuff to get rid of this. And it looks like okay, well, how would we do that actually? I'm guessing they could take care of this top part, but I'm also guessing that they'd have to multiply both sides by -5 minus X. And that would get rid of this fraction, but then you'd have to double these 2 numbers here, -10, -2X. And then from there, you would just solve using basic algebra. And it looks like you do the same thing on this side here because we're missing one of the Y values. But we have A and, well, we don't have B actually. So it looks like we're gonna have to go with CD first. So line CD, get the slope. And we're gonna have to set it equal to the opposite reciprocal. So instead of 5/3, we're gonna set it equal to -3/5. Now, with this one here, you might have a small trick that you could use. That small trick is called cross multiply. You've probably heard of it before. In fact, I'm not sure where students learn it, but a lot of them seem to kind of already know it. So when I say cross multiply, it's like, boom, goes off in their head. Oh, you mean, you know, crisscross multiply or something like that. You know, they'll say something along those lines. So multiply here, you got 5 times y minus 2, right? And that's how they got this part here. And then over here, -3 times, well, in this case, it'd be -10. So if I put those 2 numbers together, it'd be -10. So 3 times 10 would be 30, and that's how they got this number. So that's the only trick you'd have to learn with both of these, is that cross multiply. You could use cross multiply here as well. You'd have to put a 1 under it, turn it into a fraction, and that would make it a lot easier than, you know, because cross multiplying would just be a lot easier than working it out algebraically 1 step at a time. In fact, I don't think I did a really good job of explaining it, but now that I pointed that out, you can use cross multiply much better. All right, so that's it for this one here. I'm going to go ahead and let this one end the lesson. So we'll come back at 9:45. So we'll go ahead and go into independent student learning. I am going to have to, well, let me just go ahead and stop this.